Okay. Alright, so 7.5. Number 3 says to just solve the given equation. Okay. Okay, well, this is involving two different trig functions, and that's not ideal. So what we can do is replace cosine squared theta with 1 minus sine squared theta by using the Pythagorean identity. And now everything is in terms of sine, and I can distribute, so 2 minus 2 sine squared theta plus sine theta is equal to 1. And then I can reorder this, say negative 2 sine squared theta plus sine theta is equal to negative 1. Subtracting this 2 over. And then 2 sine squared theta minus sine theta equals 1 by dividing everything by a negative sign to get rid of this leading negative. And then I can say 2 sine squared theta minus sine theta minus 1 is equal to 0. Okay, now we need to try to factor this. Well, I could write it in terms of x if that makes it seem easier, so just letting x equal sine theta here. And now I need to factor this somehow, so I'll say 2x and x. Okay, so I need to think of two numbers that multiply to give negative 1, so it's got to be 1 and 1, and they have to add to give negative 1. So I'm thinking negative x. There, that should do it. So that I have positive 2x squared, negative x, and negative 1. Okay. Setting each of these equal to 0. Whoa. And then solving for x, I'll have x is negative 1/2 and x is 1. And now replacing x with sine theta. Okay. Both of these are within the range of sine, so no hope of getting rid of one of them because it's undefined or anything like that. Sine of theta equals negative 1/2. Where does that happen? That's going to happen in the third and fourth quadrants where sine is negative. And that's going to be this angle and this angle, which is 7 pi on 6. And the other one would be 11 pi on 6. 11 pi on 6. And then these are corresponding to this equation. Now where is sine of theta equal to 1? That's going to happen right along here at pi on 2. And that's it, right? This is one of those cases when this equation is only yielding one base angle. So the answer would just be all of these, but adding a 2k pi at the back. So if they want it in order, you would say pi on 2 plus 2k pi, comma, 7 pi on 6 plus 2k pi, comma, 11 pi on 6 plus 2k pi. Those are the solutions to this equation. Okay, number 8 says 3 sine 2 theta minus 2 sine theta equals 0. Right. Yes. So we need to use the double angle formula here. Okay, double angle formula, which is going to be 2 times sine theta cosine theta, so 3 times 2 sine theta cosine theta minus 2 sine theta equals 0. Okay, and this is going to be 6 sine theta cosine theta. And this is similar to, I think, that other problem I worked before, where we can now factor a sine theta out of both of these. In fact, we can factor a 2 sine theta. So 2 sine theta times 3 cosine theta minus 1. So I'm factoring a 2 sine theta out of both of these terms. And then, I can, now that I have them written as a product, I can set each one equal to 0. Solve each one for theta, or cosine, whichever it is. So this one just dividing by 2 on both sides, the 0 absorbs that. Then over here adding the 1 and then dividing by 3. Okay, so when is sine theta equal to 0? That's going to be here and here. So at 0 and pi. So over here, theta is equal to 0 plus 2k pi, and pi plus 2k pi. Which these can actually be simplified a little bit, because 0 doesn't do anything, so 2k pi, and then over here, actually this can all just be, it's just going to be summed up as a multiple of pi. Here we could say, well, how can we say this? Actually, these can be contained all as 1 because we're just rotating between 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. So this actually would just be k times pi. These would absorb. I'm not sure if WebAssign will still want you to write them as 2 separate answers, but it's just the way that sine of theta equal to 0 is working is we're just bouncing back and forth between 0, pi. We're just always increasing by pi, from 0 to pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, etc. Now here, this one is not a common angle, or a common coordinate, so we're going to have to use the inverse on this. And that's going to be approximately, oh, I actually don't know, 1.23, and this is in radians. And there's another base angle, let me draw it down here, where is cosine positive, that's going to be in the first and fourth quadrants. So this is 1.23. How can I find this angle all the way around? Well, I need to do a full rotation minus 1.23. That's going to be, let's see, 2 pi minus 0.23 is 5.05. And this is still in radians, so and then add 2k pi to the back of each of these to get all of the angles, every rotation landing at each of these angles. So web assign will want it as 1.23 plus 2k pi, comma 5.05 plus 2k pi. They also might ask you to round out to 4 decimal places instead of just 2. I've just been rounding to the second decimal place, but who knows what WebAssign may want. Okay, that was number 8. Number 9 is cosine 2 theta equals 3 sine theta minus 1. Okay, so we need to use our double angle formula for cosine, and since sine is involved over here, I think I'm going to rewrite cosine of 2 theta as 1 minus 2 sine squared theta. So that's coming from one of the double angle formulas for cosine. Excuse me. Now I have an equation just in sine and sine squared, so I can reorder this, get it all on one side. So subtracting 3 sine theta over, and then adding this 1 over, and now I'll divide by a negative. Okay, now I can replace sine. Whenever you've got a quadratic trig function, you're going to probably want to do this step just to make it solving this quadratic equation a bit easier to look at. I need to factor this and solve, so I'm thinking I'm just going to try and stare at it and figure out what it should be. Let's see, one of them needs to be positive and one needs to be negative, so let's see if I put a 1 here, then I have 2x. Let's see. Need to add to give a 3x. So if I put a 2 here, I think that does it. Negative x and 4x, yeah. There we go. Okay, right, negative x, positive 4x adds to give 3x, yes, okay. Now I can set each one equal to 0 and solve. Now replace x with sine theta. This has no solution. That's nice. That means we don't have to worry about finding all the angles to satisfy this. And this is one of those nice coordinates. Let's see. That's a pi on 6. And where else is sine positive? At the second quadrant, where the other angle would be 5 pi on 6. And there we go. Let's see, they had the answer listed for this one. Yep, pi on 6 plus 2k pi and 5 pi on 6 plus 2k pi. So there we go. So 7.4 and 7.5 are all about solving trig equations. And the point is that all of the trig equations, as long as you're inside the bounds of the range of whatever the trig function is, they're going to have infinitely many solutions. And for the sine and cosine functions, you're going to have 2 base angles, each with infinitely many solutions, except for that one case where you've got a 1 or a negative 1. That will just yield 1 base angle.